Yeah. So, hello students. Good afternoon to one and all. So, today we are going to discuss some questions related to hydrocarbons. Okay. So, moving on to the first question for today. Okay. Before moving on to the first question, let me give you the summary of this hydrocarbon session. Okay. So, in this lesson, we have four topics, that is alkanes, alkenes, alkynes, and aromatic hydrocarbons. Okay. So, we are going to discuss the questions based on these four topics. Under each topic, if we are taking an alkane, so we will study the nomenclature of alkane and we will prepare the alkane, okay? And we will study the physical properties and chemical properties of alkanes. Got it? So, like this, the pattern goes for alkenes, alkynes, and aromatic hydrocarbons also. Okay. So, this is the gist of this lesson. So, let us start with the first question for today. So the first question for today is to you on the screen. So the substance which forms isomeric products on mono substitution is. So four different options are given to you. So you are asked to find out the compound which forms isomeric products. Okay. So isomers means at least two compounds should be there, right? So minimum two compounds should be there. And in both the compounds, molecular formula would be same, but the structure would be different. Okay. So now three alkanes are given to you. You have to find out which alkane will give isomeric product on mono substitution. Substitution can be, you can substitute halogen, you can substitute any group. So on any of the substitution, the compound should give two products at least. Okay, then only it is capable of forming isomeric products. So we are asked to find out that. So to find out the answer for this question, so first you need to check for the different types of hydrogens present in the compound. Okay, so you can see in the first compound in CH4, all the four hydrogens are of same type. If you are replacing or substituting one of the hydrogen by a group, you will end up with CH3. Let me write the group as X. Okay, you will end up like this. Only one compound is formed on mono substitution of option 1. Okay, coming to option 2, it is C2H6. So it is CH3 and CH3, right? So what we are having, we are having 6 hydrogens, and on replacing one of the hydrogen by the some group, okay, the X group, what we will get? So all the 6 hydrogens are of same type. If you replace any of these 6, you will end up with the same product, only one product, okay? That is a formula CH3, CH2, X. Got it? Then coming to option 3, we have C3H8. So what is C3H8? It is CH3, CH2, CH3. Propane, right? So in propane, you can see there are two different hydrogens present in it. So one type is the terminal hydrogens. Okay, this is of one type. If you replace any one of these hydrogen, you will end up with CH3, CH2, CH2, H. Okay. And the internal hydrogen is the second type. Internal hydrogen is the second type. So if you replace one of the hydrogen, internal hydrogen by a group called X, you will have CH3, CHX, and CH3. Okay. So what we are getting? We are getting two different compounds for the same formula on mono substitution. Got it? So two different products are possible with same formula on substitution. And since it is the case, option 3 is the correct answer for this question. Got it? C3H8 is the answer for this. All of the above cannot be the answer for this. Got it? Yes. Now let's move on to question number 2. So the question is to you on the screen. So two different reactions are given to you, and we have to find out X and Y. Okay, we have to find X and Y. Got it? So this reaction you might have studied under the controlled oxidation of alkanes. Okay? So you see, in the first reaction, methane is reacting with oxygen to give H in presence of copper metal and on heat. So copper metal will convert the alkane to alcohol. Okay, copper metal will convert the alkane to alcohol. So since the alkane is having one carbon containing system and the product will be the one carbon containing alcohol, which is nothing but CH3OH, methanol. Okay. And in the second reaction, we have molybdenum trioxide as the catalyst, and molybdenum is the metal. So molybdenum metal will convert the alkane to aldehyde. Okay. Since the alkane is again having one carbon, we will get a one carbon containing aldehyde, and that is Y. So which is nothing but HCHO. Okay, methanol. So this is called as methanol since it is an aldehyde. And the CH3CO, sorry, CH3OH is methanol. This methanol. Got it? So X is methanol, Y is methanol. So the catalyst only determines the product. If you are using copper, you will get alcohol. If you are using molybdenum, you will get aldehyde. If you are using manganese, you will get carboxylic acid. But that reactions, those reactions are not given here, so we don't have to go for that. So just read the catalyst and the corresponding products that we get from the reaction. Okay, if two carbon containing alkane is given, then you have to take the two carbon containing alcohol and two carbon containing aldehyde. Got it? So this is how you are finding out. You are finding out the product. Got it? Now let's move on with the third question. So option 3 will be the correct answer for this. So moving on to the next question. Question number 3. So it is a statement type question. So statement 1 says that when N-butane is heated in presence of AlCl3 and HCl, it will be converted to propane. Okay? And statement 2 says that in presence of this AlCl3 and HCl, if any alkane having 4 carbon is heated, it undergoes isomerization to give a isomer of reactant alkane. So these are the two statements. We have to find out the correct answer for this question. Okay. Now, checking the statement. So let me go with the statement 1 first. Okay. So N-butane. So what is N-butane? 4 carbon containing alkane is called as N-butane, right? So now N-butane is heated in presence of this aluminum chloride and HCl. And the statement 1 says that it will be converted to propane. No. So this reaction we have discussed in the class. The name of the reaction is isomerization reaction, right? Name of the reaction is isomerization reaction. And the 4 carbon containing alkane will give, the N-butane will give isobutane. So this is the product that you get from this reaction. But here in this statement, it says that you will get propane. So we are not getting propane, we are getting isobutane. Okay, so the statement 1 is false. Coming to statement 2, in presence of this catalyst, any alkane having 4 carbon, if it is heated, it undergoes isomerization to give a isomer of the reactant alkane. Yeah, it will give the isomer of the reactant which we took on treatment with AlCl3 and HCl. So statement 2 is correct. So 1 is false and 2 is correct. So that is the correct answer for this question. Okay. Now coming to the next question. Coming to question number 4. Good afternoon, JNV Bhavnagar students. Good afternoon. So we are discussing questions. We are discussing questions on topic hydrocarbons. Okay. So keep a note of it. So coming to question number 4. So again, it is a statement type question. Two statements are given to you. Statement 1 says that The methyl iodide and ethyl iodide, when it reacts with sodium in presence of dry ether, it forms three types of alkenes. Okay. And statement 2 says that in Wood's reaction, sodium is the reducing agent. Got it? So these two are the statements. And we have to find out the correct answer for this. So JNV Bhavnagar students, can you try for the answer and let me know the answer in the chat box? Can you guys try for it? JNV Bhavnagar. Has anyone got the answer from JNV Bhavnagar? Okay, let's discuss. Okay. So now you see statement 1. So two alkyl halides are given and both of them are different alkyl halides. Okay. So basically alkyl halide on treatment with sodium in presence of dry ether is a Wood's reaction. It is a Wood's reaction. Now the statement says that these alkyl halides will give three types of halides. So we have to check for it. So we have two different types of alkyl halide. It is CH3I and C2H5I. So first the CH3I will react with 2 sodium with 1 more mole of CH3I from the solution to give CH3, CH3. To give CH3, CH3. 2 moles of methyl iodide itself will react with sodium to give ethane. Okay. Then what this ethyl iodide will do, again the 2 moles of ethyl iodide will react with the sodium in the solution. So 2 moles of ethyl iodide will react with sodium with the elimination of 2 NaI. We will get C2H5 and C2H5. This is the second product. Okay. And in the container, we have methyl iodide as well as ethyl iodide, right? So one of the methyl iodide will react with sodium with another mole of ethyl iodide. So CH3I with 2 sodium is going to react with C2H5I. So now what happens? Now on the elimination of this thing, we will get CH3, C2H5. Okay. So you can see the name of the first product is ethane and the name of the second product is butane since it has 4 carbons, and the name of the third product is propane since it contains 3 carbons. Okay. It is propane. It is propane. So we are getting 3 types of alkanes for this given alkyl halides. Okay. So the same alkyl will react with another alkyl in 2 cases. And in this last case, 2 different alkyl halides are reacting with sodium. So this is how you have to find out the product for different halides for Wood's reaction. Got it? Now statement 2 says in Wood's reaction, sodium is the reducing agent. Yes, the role of sodium is it is acting as a reducing agent only. So that statement is also correct. Both the statements are correct, but we have to check whether the second statement is correct, is the correct explanation for the statement 1. Got it? So in statement 1, we are getting 3 different products. So what should be the reason for that? The reason should be, since we are having different alkyl halides, so different number of products are formed. So that should be the correct answer. Because of this reducing agent sodium, we are not getting 3 different products. In Wood's reaction, sodium is a reducing agent. Because sodium is a reducing agent, we are not supposed to get 3 different products. Okay, in all the reactions, even if you take same type of alkyl halide with sodium, you will end up with the product, right? Sodium is going to act as a reducing agent in that case also, and it is going to fetch you the product. Got it? So, because this is the reducing agent, we are not getting 3 products. Since we are having 2 different types of alkyl halides, we are getting 3 different products. Since we are having 2 different type of alkyl halides, we are ending up with 3 different products. Got it? So that should be the correct explanation for statement 1. So the answer would be statement 1 and statement 2 are correct, but statement 2 is not the correct explanation of statement 1. Okay. So option 2 is the correct answer for this question. Got it? I hope this is clear to all of you. If you're having any doubt, you can put it in the chat box. Okay, both the students. Those who are watching from Zoom as well as from YouTube, you can text me or put it in the chat box if you're having any doubt in this question. Got it? Yes. So now I will move on to question number 5 for you. Okay. Question number 5 is to you on the screen. The IUPAC name of the following. The IUPAC name of the following form. So can you guys try for it? Can you guys try for it? Can you guys try for the answer? It's very easy, right? Can you find the IUPAC name of the given hydrocarbon? It is an alkane, right? So just try for it. So let me draw the structure. Let me draw the structure for you. So it is, just a second. Yeah. It is C, which is attached with 3CH3, and the carbon is attached with CH2, and this particular carbon is attached with CH3. Got it? So this is the given compound. Now, which is the parent chain? 1, 2, 3, 4, 5. This is the parent chain. Now to the second carbon, 2 methyl groups are attached. And to the fourth carbon also 2 methyl groups are attached. Okay. So now what should be the correct answer? 2, 2, 4, 4 tetramethyl pentane. 2, 4, 4 tetramethyl pentane is the correct answer for this. Okay. So option 1 is the correct answer. Very easy. So now let us move on to question number 6. The number of primary, secondary and tertiary carbons in 3-ethyl, 5-methyl heptane are. Okay. So you have to find out the primary, secondary, tertiary carbons in 3-ethyl, 5-methyl heptane. So let me draw the structure. So heptane means it should contain 7 carbons, 5, 6 and 7. And to the third carbon, we are having an ethyl substituent. And to the fifth carbon, we are having a methyl substituent. Got it? So this is the structure. So how to find out the primary, secondary and tertiary? If a carbon is attached with only one carbon, then that compound or that carbon is called as primary carbon. Okay? If a carbon is attached with only one carbon, it is called as primary carbon. So now you check for those kinds of carbon in this compound. So you can see this terminal carbon. It is attached with only one carbon to the right side of it. So it is the primary carbon. Okay. And like this carbon is primary. And this is also attached with only one carbon. So it is also primary. And this terminal carbon is also primary. Okay. So totally how many primary carbons we are having? 4 primary carbons. Okay. Coming to the secondary carbons. Secondary carbon means a carbon should attach with 2 carbons. Carbon should attach with 2 carbons. Okay. So you can check, you can see that this carbon is attached with 2 carbons with it. And it is also the same case. This carbon is also having secondary. And this is also secondary carbon. So we have 4 secondary carbon in the structure. And moving on to tertiary, what is tertiary? A carbon which is attached with 3 carbon is called as tertiary carbon. So like this, we are having 2 tertiary in this compound. So we have 4 primary, 4 secondary and 2 tertiary. So option 2 is the correct answer for this question. Got it? Option 2 is the correct answer for this question. Clear to all of you? Yeah, now let's move on to the next question. When sodium butyrate is subjected to decarboxylation and Kolb's electrolysis, it gives. So it is a reaction, right? Two reactions are clubbed here, and we should know the structure of sodium butyrate. Okay. So what is sodium butyrate? CH3, or let me write C3H7. Okay. So it is a propyl group containing system with COO minus and Na plus. So this is called as sodium butyrate. Now this is subjected to decarboxylation. What is decarboxylation? Removal of Na2CO3 with soda lime. So who is the soda lime? Sodium hydroxide and calcium oxide mixture on heating is called as soda lime. So this mixture is called as soda lime, and this reaction is called as decarboxylation. So during this reaction, Na2CO3 will come out. From where does it come out? Na2CO3 will come out like this. So this C3H7, it goes and form the bond with this hydrogen. Okay. So what we will get? We will get C3H8 as the product. Okay. We will get RH as the product in decarboxylation. Okay. If you are taking RCO minus Na plus, we will end up with RH. So this reaction is called as decarboxylation. Okay. Now coming to Kolb's electrolysis, reaction for the same sodium butyrate, C3H7 CO minus Na plus, 2 moles you have to take and 2 moles of water we have to add. Okay. Now this undergoes electrolysis process to give RR. To give RR. So here we took RCOO minus and Na plus. So we will end up with RR. Got it? So who is the R group there? C3H7 is the R group, right? So we will end up with C3H7 and C3H7. Okay. With the elimination of some more hydrogen, carbon dioxide, and sodium hydroxide as the byproduct. Okay, those are the byproducts. Hydrogen, carbon dioxide, and NaOH, all these are the byproducts. So this is the main product. So in this main product, we have how many carbon? We have 6 carbon and 14 hydrogen. Okay. So this is the product from Kolb's electrolysis. So sodium butyrate gives C3H8 and it gives C6H14 with Kolb's. It is given in option 2. Okay, so option 2 is the correct answer for this question. Option 2 is the correct answer for this question. Got it? Guys, do any of you have any doubt? If you're having any doubt, just put it in the chat box, okay? Let me move on to question number 8 for you. So question number 8 says that C2H5Cl is reacting with alcoholic KOH to give compound A, and compound A on treatment with dilute H2SO4 with H2O gives compound B. A and B are. Compound A and B are. Okay. So it is very easy, right? So two reactions are clubbed here again. So let me write the reactant for you. It is C2H5Cl, which is nothing but CH3, CH2, and Cl. Okay, this is the reactant. And it is treated with alcoholic KOH. Okay, so in alcoholic KOH, we have K plus and OH minus. So what is the role of this alcoholic KOH? It undergoes, okay, it leads to the elimination. It leads to the elimination. What type of elimination? Beta elimination will occur if an alkyl halide is treated with alcoholic potassium hydroxide. Okay. Now we have to find out which is the beta hydrogen. The chlorine attached carbon is called as alpha carbon. The carbon which is adjacent to alpha carbon is called as beta carbon. And the hydrogens which are attached with beta carbon, they are called as beta hydrogens. Okay. So now what you do? Take this OH minus and attack this hydrogen. Okay. Well, OH minus will take off that hydrogen, which is the beta hydrogen. The bond shifts here. CCl bond breaks and the Cl goes out. Okay. So what we are getting? We are getting CH2 double bond CH2. Okay. HCl has gone out, and I mean OH minus has taken H. H2O has gone out. KCl has also gone out. Now this is compound A. This compound A is treated with dilute H2SO4. It's treated with dilute H2SO4, and hydration is occurring. Hydration, acidic hydration. Okay, this reaction is called as acidic hydration. We are adding the water molecule, so it is called as hydration using an acid. So it is called as acidic hydration. Okay. Now what happens when an alkene is treated with acid and H2O? Markovnikov's addition occurs, right? So it undergoes Markovnikov's addition. So what is Markovnikov addition? So in the addition molecule, we have H2O, and H2O contains H plus and OH minus. So you break one of the pi bond and add H to one carbon and OH to the other carbon. Since the alkene is given alkene is symmetrical alkene, we can add OH and H to either of the double bonded system. Okay. So we will end up with CH3, CH2, and OH. If some other alkene is given to you, if unsymmetrical alkenes are given to you, then you have to go for Markovnikov addition. Okay, for unsymmetrical alkenes, you have to go for Markovnikov addition. That is a negative part. Negative part of the addition molecule will go to the carbon, which has less number of hydrogen. Okay, that is Markovnikov addition. So in this alkene, you don't have to follow that because it is symmetrical only. So we are ending up with CH3, CH2OH, which is called as ethanol. So now the compound A is C2H4 and compound B is C2H5OH. So where it is given? It is given in option 2. It is given in option 2. Okay. So option 2 is the correct answer for this question. Got it? Yes. Now coming to question number 9. An alkene on vigorous oxidation with KMnO4 solution produces only acetic acid. The alkene is. So what is the answer for this? Alkene is treated with KMnO4 and it is giving acetic acid. So if it is giving acetic acid with KMnO4, the alkene should contain 4 carbons and it should be symmetrical, because in acetic acid we have 2 carbons, right? We have 2 carbons. So the alkene should be a symmetrical alkene. Then only on oxidation with KMnO4 it forms carboxylic acid, which is the acetic acid. Okay, and acetic acid contains 2 carbons. If it is a symmetrical alkene, then on breaking the alkene here and converting that into carboxylic acid, you will get the CH3COOH and CH3COOH. So it should be option 2. Answer should be option 2. Okay. So then only you will get only acetic acid as the product. For the other alkenes, if you check for unsymmetrical alkenes, you will end up with 2 different carboxylic acid. Okay. So only in option 2, you will end up with only one type of compound with the 2 moles of it. So that is acetic acid. Got it? So this is question number 9. And moving on to the next question. So ethene is reacting with bromine to give A, and A is reacting with zinc to give B. So we have to find what is B. Okay. So the options are given to you: acetylene, ethylene, ethine, and methane. Okay. So let me write the reaction. So ethene has CH2 double bond CH2 as formula, and it is treated with bromine. So to give compound E. So this is basically the addition of halogen to double bond, right? So break this bond, add one bromine here and another bromine here. You will get CH2Br and CH2Br. Got it? So this is compound A. And this compound is reacting with zinc, and on strong heating it is giving B. So usually the zinc, what it will do, it will take this 2 bromine and goes out as ZnBr2. Okay, and the double bond is formed between the carbons which carries those halogens. So what we will get? We will get CH2 double bond CH. Okay. So this is the product and this is compound B. The name of this compound is ethene. Ethene is the IUPAC name of this compound, and ethylene is the common name of this compound. Ethylene is the common name of ethene. Okay. So we are ending up with ethylene. See, acetylene means it is C2H2. So that is not formed. We are getting C2H4, right? So it is ethylene. Option 2 is the correct answer. Very easy. Two reactions are clubbed here. That's all. First is the addition of halogen. Second is the reaction of vicinal halide with zinc. Okay. Everything is very, very easy. Let us move on to the next question. Question number 11. Which of the following alkene on acid catalyst hydration form 2-methyl propan 2-ol? So 4 alkenes are given to you and it is undergoing acid catalyst hydration and it is giving an alcohol. And that alcohol contains how many carbons? So 2-methyl. So methyl has 1 carbon and propane contains 3 carbons. So totally the alkene should contain 4 carbon in it. Okay. If you check for the options, option 1 contains only 3 carbons, so that cannot be the answer. Option 2 contains 6 carbon, it is also not the answer. Option 3 contains 2 carbon, that also cannot be the answer. When you check for option 4, it has 4 carbons. So that should be the correct answer. So let me show you the addition of this H2O also. Okay. On addition of this H2O in presence of acid, one of the pi bond gets broken down, and hydration means addition of water. One of the previous question I told you, no, it is addition of water in presence of acid. Okay. So water contains H plus and OH. So break this, and this alkene is unsymmetrical. So the negative part will go to the carbon which has less number of hydrogen, and the positive part will go to the carbon which has more number of hydrogen. So what is this? It will give CH3, CH3 and OH, CH3. Okay. 1, 2, 3. So the second carbon has methyl. So 2-methyl propan 2-ol is the product from the compound which is present in option 4. So that is the correct answer. Got it? Now moving on to the next question, that is question number 12. Question number 12. So it is a statement type question. Ethene does not show geometrical isomerism and alkenes cannot show geometrical isomerism. So ethene, so what is the formula for ethene? It is C double bond C, H, H and H, H, right? CH2 double bond CH2. This is ethene. So for a compound to show geometrical isomerism, which is otherwise called as cis-trans isomerism, the two of the hydrogens of both the alkene carbon should be substituted with some other groups. Okay, 2 of the groups should be different. Then only a compound can show geometrical isomerism. But in ethene, you can see all the groups are same, which is hydrogen. So ethene cannot show geometrical isomerism. Statement 1 is true. But you see the statement 2. Alkenes cannot show geometrical isomerism. Is that right? No, that statement is wrong. Except ethene and propene, all other alkenes will show geometrical isomerism. Suppose if I am taking butene, but-1-ene will not show all 1-enes will not show. If you go for 2-ene, 3-ene of the corresponding homologous of alkenes, they will show geometrical isomerism. If I am taking but 2-ene, you check. So this is but 2-ene. Okay, this is but 2-ene. So in but 2-ene, we have 4 carbon, and between second carbon and 3 carbon, we have a double bond. So it is but 2-ene. So now the similar groups are present on the same side of this double bond. So it is called as a isomer. If I change this position here and this position here, I will end up with the similar groups on the opposite side of the double bond. So that will be the trans. Okay. So this is one of the example which shows geometrical isomerism. Some alkenes, they show geometrical isomerism. But in statement 2, it says that it cannot show geometrical. That is incorrect. Okay. Statement 1 is true and statement 2 is false. Statement 1 is true and statement 2 is false. Okay. So now coming to the next question, question number 13. So again, a statement type question. So the acidic character of ethane, ethene, and ethine are given. Okay. So the higher the F character in the hybridization of carbon atom, more is the acidic nature of hydrogen. So let's check. So what is the compound given at first? It is C2H2, right? So which is nothing but ethine. So ethine has sp hybridized carbon and ethene have sp2 hybridized carbon and ethane have sp3 hybridized carbon. Okay, we all know that the sp hybridized carbon containing systems are more acidic than sp2 than sp3. So this is the acidic order. Okay, this is the acidic nature of the hydrocarbons. So statement 1 is correct. Statement 1 is correct. Ethine is more acidic than ethene and ethene is more acidic than ethane. Okay, so this compound is ethane, alkane, and this is your ethene and this is your ethine. Statement 1 is correct. So why sp hybridized carbon containing compounds are more acidic? The reason is percentage of S character. Percentage of S character is directly proportional to acidity. Okay. So the percentage of S character is more in case of Sp. In case of Sp, the percentage of S character is 50%, right? So S and P both are having 1:1 ratio. So it is 50-50%. And in case of Sp2, if you see, percentage of S character is 33.3 and percentage of P character is 66.6. And in case of Sp3, so 1:3 ratio, right? So S character is 25% and P character is 75%. So when you observe this, the percentage of S character increases from Sp3 to Sp. So Sp is having the highest S character. So that is more acidic. That is more acidic. So that's why ethine is more acidic. So statement 2, statement 1, both are correct. And statement 2 is the correct explanation of statement 1. So if percentage of S character is more, why do the acidity has to be more? That should be the question arising in your mind, right? So I will tell you the answer for that. Acidity of sp hybridized system is more because electronegativity of the sp hybridized carbon is more. Okay, electronegativity of the sp hybridized carbon is more. Okay, it is also directly proportional. If electronegativity of sp hybridized carbon is more, suppose here in this case, in ethine, these two carbons are sp hybridized, right? Means these two carbons are more electronegative in nature. So what is meant by electronegativity? The tendency of an atom to attract the shared pair of electrons towards itself is called as electronegativity. So what this carbon will do? Since they are more electronegative in nature, they will try to keep these shared pair of electrons towards itself. Okay. So what happens to this hydrogen? It goes out as H plus ECD. will give its electron to carbon and it will go out as H plus easily. So the compounds which donate H plus ion easily are called as acids. The compounds which donate H plus ions easily are called as acids. So that's why ethine is, or the sp hybridized carbon containing compounds are more acidic than the others. Got it? So I hope this is clear to all of you. So option 1 is the correct answer for this question. Got it? Now coming to question number 14. Coming to question number 14. Going to question number 14. In the following sequence of reactions, the product D is. So ethanol, ethane, ethene, and ethane. So what is the product? So you see the sequence. Ethine is reacting with HBr. So it is nothing but the addition of HBr, right? So break the bond, add hydrogen and Br in this manner, and it will give you CH2 double bond CH and Br, right? So this is compound A. And again to this compound A, HBr is reacting. So again you have to add this, the second mole of HBr. So we have an alkene, break the second pi bond, and now we have to follow Markovnikov addition. Okay. So the negative part, H plus and Br minus, right? So the negative part of the addition molecule goes to the alkene carbon, which has very less number of hydrogen. So you see here, the first carbon contains 2 hydrogen, the second carbon contains only 1 hydrogen. So the negative part will go to the carbon which has only 1 hydrogen, that is the second carbon. Okay. So you have to add bromine to this carbon and hydrogen to this carbon. So what we will get? We will get CH3, CH. Already one Br is there. Now we have added another Br also. We have added another Br also. This is compound B. Now this compound B, let me write it again for you so that it will be more clear to all of you. So what is compound B? It is C, H, Br, Br and CH3. This is compound B. Okay. Now this compound B is treated with alcoholic KOH. So we all know the role of alcoholic KOH, right? So it will do elimination. What elimination? Beta elimination. So who is the beta hydrogen? Bromine attached carbon is alpha and this is beta. So one of the beta hydrogen is attacked by the OH minus. The bond shifts here and CBr bond breaks. So we are ending up with CH2, double bond, CH, CH, Br. Okay. I write this hydrogen also with bonds so that it will be easy for you to understand the next reaction. Okay. So we are having CH2, double bond, CHBr. So this is compound C. Now this compound C is reacting with NaNH2. So what is the role of NaNH2? It is also a base. Sodamide. It is called as sodamide. It is sodamide, which is a base. Okay. So Na plus NH2 minus. So since it is also base like alcoholic KOH, it will go and eliminate the beta hydrogen. Now who is the beta hydrogen? This is alpha and this is beta. And these two are the beta hydrogen. So eliminate this, shift the bond here, and the CBr bond breaks and goes off. So we are having CH, triple bond CH. So this is compound D. Okay. And NH2 has taken this hydrogen, so it goes out as NH3, and Na and Br will react to give NaBr. Got it? Now we are getting C2H2, which is called as ethine. Which is called as ethine. So the product D is ethine. So option 4 is the correct answer for this question. Option 4 is the correct answer for this question. Okay? Clear? Yes. Now, moving on to the last question for today. So, C2H2 with NH3 gives A, and A on treatment with CH3Br gives B. The compound B is. So, again, what happens? Same thing happens, no? What is forming? Na, it is actually NH2. Again, the same reaction, Na plus and NH2 minus. Since we have acidic hydrogens here, the base can attack the acidic hydrogen so easily. So we have two acidic hydrogens. So the base will come and attack one of this acidic hydrogen to give the product which has pH triple bond C minus Na plus. Okay, the salt kind of substance is formed. This is compound A. And this compound is treated with CH3Br. What happens? NaBr will go out and there is a formation of carbon-carbon bond. H, C, triple bond C, and now it is forming the bond with the alkyl group present in CH3Br. Okay, plus NaBr is going. Now this is your compound B. This is your compound B. So in which option you can find this compound? B. It is in option 2. It is given in option 2. Okay. Yes. So I think we can discuss one more question also. So I'll give you the question. So calcium carbide is treated with water to give A and B. And from that A and B is reacting with 1 mole of sodium to give C. And C is treated with ethyl iodide to give D. We have to find out the D. So now calcium carbide is reacting with water. This reaction is given in the book and you might have studied this in the class also, right? So calcium carbide with water forms calcium hydroxide and ethyne. Okay. So this is compound A and this is compound B. Now this compound B, which is ethyne of formula C2H2, this formula C2H2, it is treated with sodium. Now it is the same reaction that we have discussed in the previous question. So what happens? Sodium is also a kind of reducing agent. It will take this acidic hydrogen out. So we will get H3 minus Na plus. So this is compound C. Now again the same thing with C2H5I. Now C2H5 is the alkyl group. Iodine is the halogen. So NaI goes out and we have CH triple bond C with C2H5 plus Na. Now this is your compound D. So let me write the compound D in a proper way. We have CH triple bond C, and to this C we have C2H5. I'll write C2H5 as CH2CH3. Okay. Now we have to find out the IUPAC name of this compound. So triple bond gets the first priority. 1, 2, 3, 4 carbons are there. So it is called as 1-butene. Okay. Since it has triple bond, it is alkyne. And triple bond is between carbon 1 and 2. So I'm giving 1 here. So option 4 is the compound D that we are getting from this reaction. Got it? So I hope this is clear. And the session is very useful for all the class 11 students who have listened to the lecture. So if you're having any more doubts, you can feel free to ask me in the next class. Okay. So thank you all for listening to the class students. Thank you so much. Thank you. Take care. Bye-bye.